My name's Dara Dotz, and I'm here to talk to you about making for good. And that's really... Speak higher? Can you guys, is that better? Forgive me, I've never held a mic like this before, so please raise your hand if you need me to speak up or go like this. So my name's Dara Dotz. I'm here to talk to you guys about making for good. And I'm a co-founder of an amazing organization called Field Ready. And I'd love to answer questions for you guys about that later. And I'm here to talk to you about outer space to the edge of disaster, building resiliency at the extremes. And I guess I have a clicker here. So I thought I'd start off by telling you a little bit about myself. I've been working as an industrial designer for over 10 years now, and I focus on disenfranchised communities, people in crisis. So I've worked and studied in this area in over 37 countries. And I've really, in the last 3 years, been focusing on how to use technology to benefit the other 90% of humanity. Because a lot of people don't have what we have here in America. So these images here are when I was actually in Nepal. As you guys know, there's a recent tragedy, the earthquake in Nepal. 4 years ago, I was living in Nepal with a community in the Langtang, doing research on how we could empower them through what they had available. On the right, we were doing different ways of building habitats, utilizing mud and recycled bottles to create more earthquake-safe homes. And on the bottom right here, I had the privilege recently of going with our UAV group called Halo Drop. We do incident and crisis response using UAVs. And we were honored by being able to fly out to Nepal and support Team Rubicon to do search and rescue efforts with, I'm sure you guys are familiar with quadcopters and octocopters. So we were flying thermal sensors to find people in the rubble, doing search and rescue. What's interesting about this to me, and is actually a really big concern for me, is that everyone's heard about Nepal, right? Well, the earthquake just happened just under 3 months ago, and it's not in the news anymore. It's not the sexy disaster, right? It's not the one that everyone gets excited about. They're looking for the next big ride, the next big rush. So this brought me, all this work I've been doing has brought me to disaster zones and extreme environments. And so when I went down to Haiti, I went down there for 3 weeks to see what it was like in phase 3 of a disaster. I wanted to see what the system looked like after people had helped, after it had been a couple years. What did Haiti look like? And unfortunately, it still looked like the disaster had happened 3 weeks ago. What I found time and time again were broken systems. I wound up working with a water startup down there, doing research with the culture to see why all these water treatment facilities were rotting and broken. And time again, I found a common thread. People weren't trained properly to maintain these wells. They weren't trained properly to contact people. They had no access, they had no training to fix it, they had no access to parts to fix the wells. There were no replacement parts in the country because a lot of the materials were brought out of country into Haiti. And if there were parts in Haiti, the parts were so expensive that the common man couldn't purchase them. And if you were lucky enough to be in a community where people were still paying attention to you and still donating time and money, it would take 3 months to 36 months to get your supplies in, because the supply chain is so corrupt and so broken. So people just can't get access. So these are some of the images here, and people still make a way. People still struggle, but they still find a way. These are some of the builders I work with in Port-au-Prince. You can see in the clinic here, I guess I have a pointer. Here, people are taking whatever they have to make do. So this is an IV bag hook with medicine. They don't even have clips or hangers to hang IV bags on in the clinics. I mean, this is how dire it is, right? Here are 2 boys taking whatever plastic bottles they found to fill with water from an irrigation ditch. So dirty water still. Here is from the TB clinic, TB HIV clinic that I've worked in a lot, where they have oxygen mixers. They could be back online, but they're broken because one little part broke. Could you imagine if we could build that one little part and get all of those mixers back online? How many lives we could save? How much money we could save donors and be more effective? Instead of purchasing a whole new machine, we could just get the machine back online. So these are the kind of things that I've been looking at in Haiti. So while I was down there, I made some friends. And this is my friend, Nurse Maeve. She's an angel. She's really actually quite amazing. She was down there in a region where there were no medical professionals. She was the only professionally trained medical nurse in the area. And so she wound up having to run a hospital, which is really to us like a small shanty shack, and 3 cholera treatment centers. And what this meant, because it was no longer the sexy disaster, is that people had forgotten about Haiti. Nobody was donating supplies anymore, so people simply had no access. So here was a night when I was there with her, and she had one pair of latex gloves left. One pair of gloves left. That's all she had as medical supplies. And she had to deliver 5 babies in one night. So in order to prevent neonatal sepsis, instead of taking a string off the ground or a rubber band, she cut the fingers off of her latex gloves to tie off the umbilical cords on the infants because she didn't want the children to get sick. This meant that she put her own life in jeopardy because she was now barehanded delivering babies to potentially HIV-positive women. And this is when I said, enough is enough. Something has to be done. I've heard of this thing called 3D printing. Let's figure this out. So we started working on prototyping and iterating what a clamp could look like, an umbilical cord clamp. And with that, we realized, here I was, I wound up getting on my social networks. As soon as I found power and internet, I reached out on Facebook, it's a beautiful thing, and got someone to donate an old 3D printer. And before I knew it, I was sitting in a shipping container in 105-degree weather, hiding from mosquitoes, malaria, and dengue, getting high off ABS fumes, as I'm sure we all have if you played with a 3D printer, making medical devices, right? The next thing I needed was an engineer and other experts to build a team to really build this out. And this is where I got really lucky and was able to co-found an amazing project called Field Ready.
We've prototyped 6 different designs today. We made one, we tested it, we went, hey, it's good, but if this clip was a bit more solid, that would be better. Okay, change the design, print another one, 10 minutes later, that's a better clip.
So that's Mark, one of our mechanical engineers, and he came down and he and I just totally went to town designing and working with locals to create the perfect umbilical cord clamp for each clinic that we worked at. Each one had a different need. And the reason the clamps are so relevant in Haiti, it sounds silly because it's a small plastic thing, is because a lot of the hospitals and clinics, women can't actually make it to the hospital when they go into birth, when they go into labor. And so it's a 2-day walk down the mountains. And so this way, a traditional birth attendant, which is really a woman who's never been trained but has been given birth before, can actually easily clamp off the umbilical cord without the child getting sick. So that's why they're so relevant and why we were looking at how we could use these as an example for 3D printing and producing on demand. So Mark was with us this last trip to Haiti. And our most recent trip was really about focusing on building our team and solidifying who we are on the ground and out. And so we were able to combine experts, designers, humanitarians, locals, and worked on problem identification. So where the hitches were, where those screws were missing, so we could produce them for them. What our opportunities were for building. And so we iterated a lot of different solutions and products. When we did our research, we went to a number of clinics, both in Port-au-Prince and north. And we found, as you can see here, these S-hooks. These are IV bag hooks that we created that snap on the oxygen tanks, so the wires no longer get confused or wrapped up and create problems. Those are nebulizer adapters. And as you can see at the top, a whole bunch of umbilical cord clamps, right? Each one was a different tailor-made for that clinic and what those women needed in those environments. Up here are our guys, as we lovingly call them. So that's Willio, Frankie, and Johnson. And they're 3 men that we met from Cité Soleil, which is a very impoverished part of Haiti, in the slums. These 3 men are not educated traditionally. And they came to us and they were really excited about 3D printing and learning about it and making and creating solutions. And so now we've been working with them and they are actually producing these umbilical cord clamps and other medical devices for the rural clinics in Haiti. And what's amazing about this with hyper-local digital manufacturing is this example here. So this man on the right, we met him on our last journey. Unfortunately, he was attacked in his home with a machete. He couldn't escape, and so he put his hands up to protect himself. And what happened is he wound up losing a number of fingers and part of his left hand. So what's amazing about on-demand manufacturing is that how could we have known we'd meet someone who was missing, 2 fingers and a hand? Instead of bringing down a bunch of bulk prosthetics, we were able to actually customize and now make him a customized prosthetic for exactly his needs. And
Field Ready is providing humanitarian aid by improving logistics and supply chains.
Real Hope for Haiti is a small clinic up north. They provide women in the agriculture areas and out in the mountains where they have no access to hospitals with birthing kits. So they've asked us to provide them with umbilical cord clamps. And this is really useful because they can then print an umbilical cord clamp in less than 8 minutes.
It's a standard tension that can be used. It's easier to keep clean and to help mother and baby stay healthy and safe and infection-free.
So now Mark is showing the guys the prototypes of the clamp, and so they're going to learn, they're setting up the printers to do the prototyping and testing.
There's always going to be things that on the ground we can't anticipate.
Haiti is a really good place as a test bed to figure out and test out all the things that could happen in disaster.
We've been able to test our equipment, test our approach, and test our people to see that all these things can come together for future more challenging countries.
So we're lucky enough to have Eric, our fearless leader, in the audience right now. So he was the one talking in the video about what we've been up to. So that was shot in our most recent trip to Haiti. And I just really want to show you a little bit more, get a feel for what we've been up to. And so what we discovered working in Haiti is a number of things. This is our most recent iteration of the umbilical cord clamp. Over here, this is Johnson. He's actually working with a new 3D printer, and we've been experimenting with recycling materials from the 3D printers. So once the umbilical cord clamp is used, they bring it in, we sanitize it, grind it up, and produce a new tool like an oxygen splitter. That means we're creating a closed loop system in manufacturing so that people have more access and the prices dropped drastically. Over here this is my favorite part of this presentation actually. So this is Johnson. Again, I said that the guys are uneducated and came from a really impoverished community in Haiti. What's incredible about this is he's here actually teaching trained medical professionals in Haiti how to make their own medical devices. I'm gonna let that sink in for a minute. Like, that's kind of powerful, right? All with making, all with prototyping and on-demand manufacturing. And so now we're hoping and supporting them to create jobs so they can keep doing this and teaching others. So now I want to talk to you about how amazing, I don't want to just talk about 3D printing, but on-demand manufacturing is, both on planet and off. So here's another project very near and dear to my heart. It's called Made in Space. Have any of you heard of Made in Space? One of you? Great, perfect. So I can tell you guys a little bit about it. So Made in Space is really about this. It's 2015, and we're still not an interplanetary species. I mean, what the heck? Where are our flying cars? Why aren't we living on the moon, right? What's going on? What are the big roadblocks here? As Stephen Hawking, one of the greatest minds of our time, basically said, we have all our eggs in one basket. What are we doing? We need to start spreading out, right? What if an asteroid comes? What if anything happens, right? And so Made in Space was started by a number of young men at a group called Singularity University in the Bay Area. And this is actually my day job. I get to work with them. It's pretty fun. And we're based out of NASA Ames. And what we're looking at is, what are the challenges of becoming an interplanetary species? First, how do we live there? How do we get stuff up to space? What are we going to do? How are we going to get things there? As you guys have seen, sadly, a lot of the rockets recently have been exploding with payloads that we're trying to get to our fearless heroes on the International Space Station. And so this is what we've been looking at. So what we looked at is, how are we going to start building in space, in situ, from materials we find there? Because right now, to get anything to space, it averages around $20,000 per pound to get anything up to space. So here's our test flights. So these are our founders here. And so what we wound up doing is our founders like, well, hey, if we can get the material and we don't have to send 8 spoons to the space station, they only need 1, why don't we make something that can build anything out of a bulk material? And so they thought, let's start doing 3D printing in space, right? So they thought, oh, we'll just take a MakerBot, we'll just take a cube, we'll just take a whatever tabletop printer, and as some of you might know, they're not the most dependable of printers, right? And they started flying them, and what created was this really expensive plastic, bad-tasting spaghetti, right? Because it turns out printers are based on gravity, and that created a challenge. So we wound up customizing our own 3D printer. It's 96% ours. Some of the things we didn't think about, heat rises here, right? It doesn't rise in zero gravity, right? So our extruders had to be changed. We had to think about surface tension. How are we going to get our print to stick? What's going to work? And so these are some of the adventures we had. And what we wound up doing, as you can see here, is it's printing perfectly in zero gravity. Now with these tests, the flight parabolas go up and down, right? So we only get 15 seconds of zero gravity, which means we also have, when we're coming up, double the gravity force, right? So instead of only printing for 15 seconds, we realized that we would develop the printer to work in double Gs as well. So now what we created is this incredibly strong, robust 3D printer that actually works every time you use it. I swear to God. It's incredible, really. I can't wait till they're ready for us, right? So it's not quite as expensive. And so it's this incredibly robust printer, and we were excited, and NASA approved it, and we got to send it to the International Space Station last fall. So here, I'm going to talk to you guys a little bit about launch. It was super exciting. I had the pleasure last fall of going to Cape Canaveral with a number of astronauts, with engineers, with scientists, and space geeks. And we had an amazing time really seeing our printer take off. So we were on SpaceX 4 Falcon 9, and this is the launch. And we were all waiting with bated breath because while we finally got our payload up, we didn't know if the rocket was going to make it. So another reason this is a really interesting project, right? So we were thrilled. I put it on mute because there were some profanities. We were really excited. I may have been drinking a little bit of champagne, just saying. It was a really momentous occasion, not only in our lives, but I think in the planet and what this means for humanity. So there goes our rocket. Just a little excited. And here it is. So it made it. We docked with the International Space Station. The astronauts put in the printer for us. So this is the glove box. So this is the zero gravity glove box. This is where science experiments are done on the International Space Station. This is our printer. And what's interesting about our printer is we designed it to save astronaut crew time because the astronauts are really busy. So we designed the machine so that we would actually operate it from Earth. So we sent the machine up with 14 different CAD files, and then we basically hit print, so the astronauts didn't have to do anything. So every piece we made, we operated from Earth. And so here's the next one. So here's some of the parts we made. So these are the 14 parts. Each one was to see, we wanted to test out containers and sockets, but most of these are really strength and tensile coupons because we wanted to compare how it printed in zero gravity to how it prints here on Earth, like the adhesion, if we can actually use it as a tool, will it help the astronauts? But the most amazing piece about this program, since we're operating it from Earth, we wanted to see if we could email a fix to the ISS, right? Have you guys all heard of Apollo 13? Some of you, anyone? Anyone raise your hand? Okay, great, thank you. So what could happen if there was a disaster on the International Space Station? We can't just send a rocket up to save them in time. It's just not possible. But what could happen if we got our engineers together to create a solution and email the astronauts a CAD file? Pretty cool, right? So that was our final test. So we had a CAD file prepared. We were going to email it. And then we overheard on the radio astronaut Butch, commander of the International Space Station, saying, man, I wish I had a ratchet. Then we could actually test out the socket. So of course, what did we do? We scrapped everything and made him a custom ratchet and emailed it to him, to the space station. So he had no idea we were doing this. We didn't tell him. We got approval from NASA. We sent it up. And here's Butch. It's like Christmas morning. I mean, it's pretty hard to surprise an astronaut. I mean, they've planned for years for everything, but look at his face, right? Pretty awesome, right? And so here it is. So now we've actually emailed hardware to space, right? So we're making on-demand in materials what they need when they need it. Similar to that in Haiti and disaster zones. When people need a medical device and they can't get access to it, we can now email them a file, right? People don't think about that. In developing worlds and in disasters, it's very hard to get access. So as you can see, space and disasters have a lot in common. So here are some more discoveries, right? So the excitement, this is like my all-time favorite photo. He is so excited. I mean, come on, you can't beat that, right? And so what happened is that excitement was contagious. So the Italian astronaut, Samantha Cristoforetti, I hope I didn't butcher her name, she got really excited. And if you guys have any idea how busy astronauts are on the International Space Station, they don't have much time. They hardly sleep. So she spent all of her free time learning how to 3D print. Pretty awesome, right? It's kind of amazing. And so this is also a friend, Dr. Yvonne Kegel. She's an American astronaut and a medical physician. She was super excited about this. And she's trying to solve problems because astronauts, when you're in zero gravity, you get bone density loss, which is what we call osteoporosis here on Earth. And so she's been working with us to collaboratively make a medical tool that we can actually 3D print on the space station to help prevent bone density loss there. And now it's going to help people here on Earth with osteoporosis. And so I really just wanted to iterate again how powerful it is to do things on demand with what you have available. So as I said before, disrupting supply chains by extreme cost reduction. If you look up here, the ratchet, oh, I totally hit the wrong button. Nice. So as you can see here, it's the ratchet, typically it would cost $20,000 per pound to get to space, and it would take years to get supplies. And now it just takes, it's millions of dollars for one payload, and now we can do it in a matter of hours for a fraction of the cost, right? It's kind of amazing. And then we can also, with the umbilical cord clamp, for that small clinic to actually get access, we figured it out. It costs $2.69 per clamp to get to Haiti. That's ridiculous. Of course, they're not going to order those because they should be doing more vital things, right? More important things. And so it just prohibitive, this cost prohibitive measures just prevent people from getting what they need when they need it. And from what we've been doing with the guys, so far we've gotten the cost down to 36 cents per clamp, which not only provides jobs for the guys in Haiti, but it's also saving donors money for supplies. And where it usually takes 3 to 18 months, it's now taking just a matter of minutes. We can print an umbilical cord clamp in less than 6 minutes at a fraction of the cost. So when a woman goes into labor, we can now print her the tools that she needs. So the other beautiful thing about printing in extremes and making on demand is really how parts can be recycled, reused, and reprinted. Again, creating that closed loop cycle. So you guys can think about how that works in space, right? So the tools that we're making for the astronauts, we can now grind up and reuse and make them something even more important. So if a disaster does strike, we can take those other things, break them down, and create something new. So we've also been having fun prototyping and producing tools out of garbage, which is my favorite part. Let's talk about upcycling and recycling. So in closing, I just really wanted to talk about how amazing it is. It's not really about giving aid or having a set solution when you go somewhere to help people and empower people through making. It's really about collaboration, iteration, and building muscle by facilitating resiliency. Whether it's in disaster zones or in space, we can all work together to come up with fantastic solutions. And if you guys would like to check out any more about Made in Space or Field Ready, please feel free to check out our website or email me. And are there any questions? Yes? Yes, that's an excellent question. You can't really open the window on the space station, right? Kind of dangerous. It'd be the only time you open the window on the space station. So yeah, so we actually had to build a sealed, contained unit that worked with ABS. We have a special environmental control unit that actually purifies the air. So because we had to develop the printer for the space station, we actually had to do a number of space and safety checks because the astronauts, we found out there are actually nanoparticles in the polymers of ABS that are actually very dangerous. So as long as you were printing at home with an open window, you're okay. But in the case of the astronauts, they don't have that option, so we made a number of really specialized filters just for those printers. Any more questions? Yes?
What were some of the things you considered when you were deciding what to be printing on the space station?
Some of the things we were considering. Well, for the initial test, we were looking at different tools to make for the astronauts, and we even played with games. Replacement parts for the space station, a lot of those. And our first test, we actually, because we collaboratively designed the printer with NASA, we did a lot of what they asked for. So when we did the ratchet for astronaut Butch, we actually, the only real time it took us about 2 days, was because we had to get NASA approval to send it up to him. But we also actually have a new printer going up at the end of this year that's completely commercial. And we'll be printing in multiple materials so that we can actually democratize space, and citizen scientists can now do things on the space station. Any more questions? Yes? Mm-hmm. That's a great question. Absolutely. So currently we do need to still ship the material. So we ship the material with the printer, and the idea is to do a one-time drop, and so that we can actually reuse and upcycle and reuse that same material. So when you're in a disaster zone, you don't have anything available, we do what we can with that one-time drop. And we're also currently researching, looking at, there's also a lot of polymers that are just strewn in the streets in Haiti right now, and we're looking at different materials that we can actually turn into new polymers for different tools. So we're keeping the virgin, the new plastic that we have for the printer, for the medical devices. And then we clean those, sanitize those, grind those up, and then turn them into other tools and products. So that's kind of how our cycle has been going. Absolutely, good question. Yes?
Do you guys have any problems with degradation of plastics?
Yes. Absolutely. That's actually been one of the big challenges about finding polymers in Haiti. So the problem with them is that they've been sitting in the sun for a long time. So finding the quality and being able to figure out how to classify and use that. So degradation does happen, but I haven't seen with what I've been testing personally, I haven't seen it happen with more than three uses so far of anything of any drastic cause. So we're actually experimenting on this next trip about how many times we can recycle the ABS, and then how we can make it to different tools and different products, which pieces need the strength, which pieces need the sealant, you know, and things like that. Absolutely. Yes?
Have you been able to find if even can be recycled, like if you made a ratchet or maybe something else, can you melt and remold, reprint using recycled?
Yes. So the question is, can we reprint and remold this material? Yes, we can. So we've been doing that with ABS currently, and that's what we did with the umbilical cord clamps. And so then we grind them up again and turn them into oxygen splitters for the clinics right now. Awesome. Anybody else? Yes?
How feasible is the reusability with the other materials that we're thinking of using for the ISIS?
The reusability. Oh, you mean the multiple materials we're setting up on the new printer?
What are the other materials and how reusable are they as compared to the ABS?
Excellent question. So we are looking into multiple materials right now. So we are sending ABS up again because it's already been NASA certified and we already have the environmental control unit. So basically, the great part about that is that we can definitely recycle ABS. The other materials I'm not at liberty to discuss right now because special, you know, agency stuff. But yeah, that's actually one of our primary concerns is looking at how we can recycle. Our ultimate goal is actually to find there's a lot of space waste floating around and how we can turn that into other tools, right? How do we get all these old satellites, pick them up, and turn them into something else with a space station? It's all up there. Why not use it for our benefit, right? Any more questions? Yes. Perfect. Excellent question. I love it. So the big thing that was the biggest hindrance. I actually meant to go into that. Thank you for reminding me. So power is definitely a limiting factor. And so the area where we set up originally is a beautiful resource center where locals and Westerners can come together and work on projects. And so we have power, rolling power, and we have a generator that we run. So when we do trips up north, we typically bring a small generator with us, or I've been kind of running around on a small motorcycle and operating little 3D printers to produce, and so hijacking the battery off the motorcycle. Yes, hi. So is our company looking beyond just... Yes. We have big goals. We're going to take over the world and the universe eventually. So stand back, hold onto your pants, hold onto your seats. Yeah, we're actually looking at a lot of things. Our goal is really to be the foremost space manufacturing company, which means that we'll be able to produce other methods of habitats. And you can imagine anything. If we're all going to live in space, what else are we going to need to make there, right? So that's our goal. So we started with manufacturing, so we can start actually building what we need when we get there. Absolutely. Anybody else? Questions? Yes. Yep. Absolutely. So actually we left the printers behind. So with the guys, they're actually now independent and they have their own printers and they produce there. And then with the power, we actually have other partners that we've been looking at out of Minnesota. And they're actually building a solar powered 3D printer. So we also have solar panels that we've set up with batteries. The big challenge is bringing these really heavy batteries into Haiti. So of course that's a bit of a challenge, but we have definitely been looking into that and other ways and other means of powering and other sources. So yes, many people ask that. Why don't we just send a shipping container with let's throw a tech shop in a shipping container? I'm gonna be the first one to say that's the worst idea ever. Sorry, people ask me that all the time because if you're gonna pack into a disaster zone, so for example in Nepal, all I had was on my back, right? And unfortunately, in a lot of these vulnerable communities, some of the people in higher power levels will take opportunity of that and steal what you have with you. So actually, I love MakerBot 1s, the Rep 1s. They still work 3 years later in Haiti. And the best thing about them is they have a wooden frame. So when I take them into Haiti and people try to con me, say, hey, you have to pay $1,000 to bring this in, I'm like, nah, it's an old junk. Look, it's made of wood. So sneaking things into the country to help people is sometimes what you have to do with different technology and power sources. Absolutely. Any more questions? Yes? Yeah, good question. So some of the clinics that we worked with, the fancier ones actually have, I forget what they're called, but they're actually like a clamp holder. So they actually, Yes, thank you. It's something like that, and it clips down. Sorry, I can't remember the name of it right now. And other clinics, they have the women, so the sizing of the way their fingers would slip off, so making the side of it easier for their fingers to grab onto, to clamp with their hands. And some of it was using less material so that they could carry it up, like large amounts of them to their back, like up the mountains and things like that. So it was just asking them how they liked it, what they liked it. And some of them, it's interesting when you speak to different women and men, what they have preference for, and you ask them and they don't know why they want to work with this part more, so we just go with what they need. So the beauty of that, they felt really empowered because they actually had a say in what they were getting, instead of just being like, here, we know better, you're gonna take this. So the level of ownership that people took with what they were getting was really powerful as well. Yeah, hi, what's your question?
Out of curiosity, what's the learning curve, the time it takes to train someone in order to use this?
That's a really excellent question, and one we've been working on. So it turns out it's pretty simple to teach people. Well, in other countries, people who've never used computers before, it's a little more complicated to teach people how to use a 3D printer and a computer, right? So it's really, we found that it's much easier to teach people how to 3D print than it is to teach people how to CAD, right? So that's really the big challenge. I think maybe all of us can agree on if you've ever tried doing AutoCAD or Fusion or SolidWorks. It's a very, very steep learning curve. So the idea is that when we go into places and we deploy, we bring the technology, we teach them how to print and how to manufacture what they need, and in the meantime, they're spending their free time learning how to do AutoCAD and design for themselves. So by the time we pull out of a disaster, they can then kickstart their own economy, create their own solutions when the next disaster strikes. So that's what we're working on. Yeah. Yes? The glove problem. That is a great question. Hopefully right now, because we're not printing in glove material, is that the idea is that once we've been building out a catalog of parts that the clinics need and they can use, that we can actually make with the materials we have. So that means a little bit of money they have left over, they can use to purchase the gloves. So that's how we're doing it. We're kind of breaking up the materials. So what can be created with what we have versus what can. Yes. Yes. Yeah. So yeah, a lot of people, a lot of us are mules. That's how I started, was sneaking in medical devices to the clinic. So yeah, any more questions? If anyone has any more questions, you can find us after the talk. I guess my time is out. And please feel free to email me at dara@fieldready.org or dara@maidenspace.us. Thanks so much, everybody.